Hello everyone, welcome to my channel. So in this particular video, I am going to discuss about this question which came into the GIT 2023. In this, you can see that the reactant and I give the two reagent that is in the first step Br2 KBr H2, or is the second step of the aqueous KOH THN. Okay, now you can see that in the reactant have no stereochemistry, whereas the product they mention the stereochemistry. So you can see this in this carbon have just they mention stereochemistry. Obviously, there is a two possibility of the product is possibility of the product. So this is the MSQ. One thing also mention I have to mention this is MSQ one or more than one option are correct. So we can elaborate this one, or you can two stereoisomer. If we write this two stereoisomer, that means one methyl ring is the up in the dash position, whereas another is the up wedge position or the upside. In the second case, methyl in the wedge and another group in the down. Okay, or the dash position. So these two are the two stereo isomer present. Okay, so that's why uh, you can see that the two possibility two of the product due to the two stereoisomer is possibility of the two stereoisomer, two possibility of the two possible product are there. Okay, now we are going to discuss about the reaction is both first one, this one. Okay, the first stereoisomer. First step is bromination step. That is Br2 is attacked from this double bond or this double bond. Any of these double bond will attack. And obviously this is the one more mole. Obviously only one double bond will mm, one double bond will bromination happen. Okay, and you see that the this is the bulky group, that's why the bromine that is come into the downside, this the here the bromine attack of the bromine in the downside. Okay, the bromine attack, you see that this is downside. Obviously the methyl group go to the upside, and brominium cyclobrominium ion is the formed. You can see this this is the formed in the downside. Okay, now in the next step we elaborate this C double H group, and oxygen have the lone pair. So this oxygen lone pair in attack here. Okay, this oxygen lone pair is attack in this carbon. That's why because of the six member ring is formed. You can see one, two, 3, 4, 5 of 6. So because of the formation of the six member ring that give the stability to the molecule, so this lone pair of the oxygen attack here, and this bond will break, and attack is come from the upside, because this is the downside. There's only one option is left, that is the only one option is left, that is the attack in the only one option is left here, that is the attack from the upside. Okay, this is you can see this oxygen come into the this oxygen come into the upside, and these two groups are as it is, that is bromine in the downside, methyl in the upside. Okay, and you can see this six member ring is in the upside. Okay, now KOH is given, so OH minus is attack in the carbonyl, or carbon of the carbonyl carbon, so, or C double bond O carbon. So when it will be attacked, then this bond will break and attack in here, and this bromine will leave. Why it is here it is attached? Because Br minus is good leaving group. That's why this this will attack here, and this Br minus this Br will leave. And one thing you can see, one thing you see, this is this six member ring. One thing you see, Now one thing you see, this six member ring is in the upside. So this bond goes in here as a upside. This bond attack here in the upside. So and this bromine will leave. Obviously this methyl goes the downside. This methyl goes downside when attack in the this is upside. So when it is attacking the upside, bromine will leave and this methyl goes to the downside, and this epoxide ring is formed from the upside, and this is the one product is formed. Okay, this is attack from the upside because the six member ring is the upside only, so attack will be happen from the upside in this carbon. And when will attack, bromine will leave, and because of the attack of the upside, obviously methyl, this methyl ring, this methyl group will goes to the downside, and this epoxide form in the upside. Okay, and okay, this is the first product. Similarly, we take the second stereoisomer, second stereoisomer. Okay, in this second stereoisomer, you can see we similarly bromination, we did the bromination. In obviously this is the bulky group. So from where did bromination happen? Obviously upside, because this is in the downside, so bromination happen in the upside. And methyl group is the downside, when bromination happen in the upside, methyl group in the downside. This is the simple things, right? Now we elaborated this CAA, right? Now this oxygen of the lone pair similarly attack from the downside because this is in the upside. This is oxygen lone pair attack in the downside, and six member ring is the form. This six member ring is formed, and this after attacking of this. Similarly, in this case, six member ring is the upside. That's why the oxygen this bond attacking from the down upside. Here the six member ring, and this six member ring is the downside. Six member ring, this six member ring, you see that this six member ring in the downside. Then whenever OH minus attack in this carbon, in this carbon or the CO double bond carbon, then this bond attack from the downside because this six member ring is in the downside. Okay, so six member ring in the downside, that's why attack is happen from the downside. Obviously when the attack is downside, then bromine is leave, and this methyl group, this group come into the upside because attacking happen from the downside. So methyl group come into the upside, attacking happen from the downside, and see obviously this bond will break and OH minus will attach. OL minus will attach. You can see that the COOH group come again. So this is the second product is formed. You can see, carefully observe these two products. See that the epoxide ring, the stereochemistry of this epoxide ring and the stereochemistry of this group are the same. Stereochemistry of this epoxide ring and stereochemistry of this group are the same. So we have to choose two options. So two options will be correct. Two options, because these two products are not same. These two options are correct in this question. Two options are correct. So we have to choose these two options. That's why this stereochemistry and this stereochemistry are the same. Now going to the option. First, this option we will cancel because no epoxide ring is there. So first we will eliminate this option. Now goes to the three option. In first option you say that this is in the downside and this epoxide ring in the downside. So it is second option you say that this in the downside and this also in the downside. This is the downside. So this is one of the correct answer. Okay. Now come into the next option. So you can see that this group in the downside, but this epoxide ring in the upside. So this is not the correct option. You said that this group in the upside and this epoxide ring in the upside. So this is one of the correct answer. So these two correct answer is A and C. This is two are the correct answer. Okay, this is the important question. You can see, you can apply that concept of this question and of the box. The first is the bromination and second is the rearrangement reaction. So thank you for the watching. Please subscribe the channel